Some more applications under CFT. Let us see now a complex nickel NST taken 6 plus 2 complex. So this particular nickel plus 2 complex is there. Let us follow the steps. Let me write nickel, that is equal to 28. Its configuration is what? 3d8 4s2. 3d8 4s2. Next, nickel is what? Plus 2 oxidation number. Nickel in plus 2. Then the remaining configuration is what? 3d8 4s0. The arrangement of 8 electrons in particular d orbitals 1, 2, 3, 4, 5, 6th electron, 7th electron, 8th electron. This is the arrangement of electrons in 3d8 configuration for nickel plus 2 in the free metal ion arrangement of electrons. Now let us write the complex NST taken 6 plus 2. NST well known to us. We already discussed it is actually strong field ligand. NST strong field ligand. Here you see, look here, electrons have to be getting paid because it is strong field. But electrons in this particular complex nickel plus 2 d8 octal geometry, electrons are not getting paid. Why they are not getting paid? What happens by the electrons are getting paid? Let us check it now. This particular d8 3d 4s 4p 3d 4s 4p. Suppose electrons are getting paid here. See, I pair up this particular 8 electrons. What happens to check it? Next, I am writing once again here 4d also, 4d orbitals. See, suppose electrons are getting paid like this, 8 electrons. Since it is strong field, generally we do like this only because strong field electrons are getting paid. But the quadrant number 6, how many orbitals you require? 6 orbitals. See, 1, 2, 3, 4, 5, 6. See how it is taking place actually. A d orbital from 3d, a d orbital from 4d are involving. What is the expected hybridization according to this particular arrangement? dsp3d. There is no such configuration, such hybridization like dsp3d. Means 2 d orbitals from 3d has to be involved or 2 d orbitals from 4d has to be involved. But 1 d orbital from 3d, 1 d orbital from 4d never involves in hybridization. There is no such hybridization like dsp3d. So after pairing of electrons, 8 electrons getting paid, only 1 orbital is remaining vacant, that is not involved. For octal geometry, you require compulsory 2 d orbitals from 3d or 2 d orbitals from 4d. Therefore, after pairing also you are getting only 1 d orbital is vacant. Therefore, the electrons are not getting paid. If electrons getting paid also, there is no possibility of a proper hybridization. Therefore, the electrons are not getting paid. They are getting now outer orbital complex only 1, 2, 3, 4, 5, 6. Then the hybridization you are getting what? sp3d2. sp3d2 electronic d2 hybridization you are getting. Because the electrons are getting paid, only 1 orbital is becoming vacant, that is not involved in hybridization or bonding. Therefore, even though nickel plus 2 strong field ligand, d8 electronic configuration, even with strong field ligand also, the electrons are not getting paid. This you have to take as what exception. So in d8 octal geometry with strong field ligands, electrons are not getting paid. You are getting outer orbital complex, 2 unpaired electrons are remaining, 2.8 is the magnetic moment. Now, splitting of orbitals for this, splitting. Six, 7, 8, splitting. EG, T2G, so 1, 2, 3, 4, 5, 6, 7, 8. This is the arrangement of electrons after splitting of d orbitals. Now let us write information about this particular complex. Information about this particular complex. Hybridization, geometry, nature of the complex I said, nature of the complex, number of unpaired electrons and magnetic moment C. Hybridization. Come to hybridization, sp3d2. Geometry. Since here coordinate number is 6, take the geometry octahedral. And the nature of the complex, it is outer orbital complex and spin free and spin free, high spin. High spin, spin free, no pairing of electrons taken place. The free metal ion and the complex, the configuration is or the arrangement of electrons remaining same. Number of unpaired electrons 2, magnetic moment 2.8 bm. This is the information about this particular complex. Exception, even though strong field ligand, in octahedral D8 system, electrons are not getting paired. Outer orbital complex is formed and 2 unpaired electrons remaining. Magnetic moment is 2.8 bm. It's very important to remember as exception from the normal arrangement of electrons. Coming to the next one. Next, let us discuss Browning complex. Fe, H2O taken 5 times, NO, and SO4. Look here, in the case of Browning complex, the iron oxidation number is Fe plus 1. This you should not forget. Wherever Browning complex is coming, take its oxidation number as plus 1. Now you see here Fe, that is equal to 26, then it will be 3d6 4s2. Fe plus, you are seeing oxidation number of iron in the brown ring is Fe plus. Brown ring is very important. In most of the entrance exams, it repeatedly appearing. Should be very careful about Fe plus. Then it is 3d6 4s1. 3d6 4s1. 6 and 4s1. Now let me write in the complex Fe, H2O taken 5, NO, sulfate. Now in this, the particular arrangement of electrons you see, (3d), 4s, 4p. Now these particular electrons 1, 2, 3, 4, 5, 6. Suppose there is electron is there in the s orbitals only. Then according to this particular arrangement, these 5 unpaired electrons are there. 5 unpaired electrons means you have to get for Browning complex a magnetic moment of 5.9 bm you have to get, as unpaired electrons are 5. But experimental results show that for a Browning complex, the maximum magnetic moment coming to be only 3.8. That means what we can understand, electron from 4s orbital, look here, electron from 4s orbital shifting to d, electron from 4s orbital shifting to d. Why it is shifting? Yes, the magnetic moment we are expecting is 5.9, but experimental results is giving information about the magnetic moment is only 3.8 bm. Therefore it has to carry 3 unpaired electron. Therefore what I did, electron from 4s orbital shifted to d, then now you are getting 3 unpaired electrons, and how many ligands are there? 6 ligands. Therefore it is actually involving 4d orbitals also in the hybridization. Therefore see 1, 2, 3, 4, 5, 6, then hybridization is what it is, sp3d2. sp3d2, this for this particular Browning complex, the hybridization is sp3d2, the magnetic moment is 3.8, It is here you have to remember electron from 4s orbital is shifted to d. This is also one exception. This is also one exception. Right now, this splitting of orbitals, then I am writing here only for 7 electrons I am taking. Yes, 7 electrons. Then splitting, it is 1, 2, 3, 4, 5, 6, 7. So splitting of orbitals is this one. Next, let us write the information about the complex. Now, hybridization, consider as what? sp3d2, yes, octahedral geometry, and nature of the complex. One electron from SE shifted to D, we agree, but still there is a choice for pairing of electrons, but these electrons are not getting paired. Therefore, you write this is outer orbital complex, high spin only we take, and spin free. High spin, spin free, number of unpaired electrons is given 3, magnetic moment 3.8 bm. This is the information about Browning complex. It is very important. It is frequently in different entrance exams appearing. A question from this particular Browning is seen many times in the many entrance exams. What you have to remember is, in this particular complex, what is the oxidation number of iron? +1. In this, NO involves as NO plus, nitrosodium ion. This particular NO is involving in the complex as NO plus ligand. So these are very important points to remember in this particular Brown ring complex. The next, let us discuss. We have completed some of the complexes under applications of CFT. Coordinate number 6 we have completed. Let me write now coordinate number 4. Let me take the first complex, nickel tetrachloride. Nickel tetrachloride, this is what -2. Then let us follow the same steps what we have taken in the coordinate number 6. Yes, now nickel, Z is equal to 28, Z is equal to 28. Its configuration 3d8 4s2, 3d8 4s2. What is the oxidation number? See, nickel is in +2 oxidation state, +2. The remaining configuration is what? 3d8, 4s0. Now, arrangement of electrons in d orbitals, check it. Now, 1, 2, 3, 4, 5, 6, 7, 8. This is what arrangement of electrons. Next, let me write the complex nickel tetrachloride. This is what -2. Cl is what? Weak field. Cl, weak field ligand. Yes, what happens by weak field ligand? No pairing of electrons. The d orbital electrons remaining as such. Therefore, I am writing without any change in the arrangement of electrons, D, 3d, 4s, 4p, 3d, 4s and 4p you take. Then 1, 2, 3, 4, 5, 6, 7, 8. These electrons are not disturbed, same as it is I written. But the coordinate number is 4. Therefore, you take 4 orbitals, 1, 2, 3, 4. This particular hybridization is what now? sp3. Hybridization is sp3, nickel tetrachloride. The hybridization is what? sp3. Then let us show the splitting of d orbital. Splitting of d orbitals, look here. Now you have to write the tetrahedral splitting. What is number 4? Tetrahedral splitting, d8 electronic configuration, look here. Tetrahedral, recollect, splitting is reverse. Higher energy level is what? T2 is the set of orbitals, lower energy level is the set of orbitals. E only let me write E and T2. Then is the difference between these two, we represent by delta T, arrangement of electrons. 1, 2, 3, 4, 5, 6, 7, 8. This is the arrangement of electrons, splitting of d orbitals in tetrahedral geometry. Next, let us see this. What is the information about the complex? Information about the complex. Hybridization, geometry and nature of the complex, and number of unpaired electrons and magnetic moment. Hybridization, geometry, nature of the complex and number of unpaired electrons and magnetic moment. hybridization, we have solved it as what sp3 geometry tetrahedral. sp3 hybridization, you know well this geometry coming to be tetrahedral. Coming to nature of the complex, leave it, nature of the complex, we need not say anything. Why? Wherever 3D is involving, we said inner orbital. Wherever 4D is involving, we said outer orbital. But here there is no participation of any d orbital. Let us say it is not an inner orbital complex, not outer orbital complex. It is tetrahedral geometry and sp3. Therefore, you don't say any either inner or outer here. Coming to number of 100 electrons, then it is 2. Magnetic moment coming to be 2.8 bm. This is the information about this particular nickel tetrachloride complex. Next, a similar type of complex, if it is weak field, what happens by taking the strong field ligand? Let me show next one more complex by taking strong field ligand. Coming to the next complex, nickel tetracyanide. Nickel tetracyanide minus 2 you take. Now, same steps let us put what the way you are taking the steps for nickel tetrachloride. Yes, nickel Z is equal to 28. This is 3D8 4S2. Coming to the next oxidation number. See, oxidation number is plus 2. Nickel plus 2. It is 3D8 4S0. 2 electrons from S is lost. D8 is remaining. The free metal ion, the arrangement of electrons. Free metal ion, the arrangement of electrons you see 1, 2, 3, 4, 5, 6, 7, 8. This one will be is the arrangement of in the free metal ion. Let me take again the complex nickel Cn taken 4 times, Cn taken 4 times minus 2. See here Cn is what strong field ligand. Yes, well known to you. According to spectrochemical series, we are classified this particular cyanide ligand is what strong field ligand. Now, in presence of strong field ligand, what happens? Say the electrons are getting paired. Now, let us pair up this particular 8 electrons in the complex. The rearrangement of electrons taking place. In the complex, the rearrangement of electrons taking place. 8 electrons are getting paired. 1, 2, 3, 4, 5, 6, 7, 8. One orbital is remaining vacant. But the coordinate number 4, we require 4 orbitals. See 1, 2, 3, 4. Therefore, 1, 2, 3, 4. See the hybridization we are clearly understanding. Here it is what D sp2 hybridization. DSP2. Next, in DSP2 hybridization, we know that square planar complex. Let us see square planar splitting of orbitals. Square planar splitting of orbitals, I show on the board. Look here. Square planar splitting. 8 electrons. We already clearly discussed what is the distribution of electrons are splitting in octal geometry, tetrahedral geometry, square planar geometry. Now here, since it is square planar complex, let us see the splitting of d orbitals in square planar. Now, you know this is what splitting of orbitals like this. Highest energy level, you know dx square minus y square. This you know dxy. This is dz square. Remaining 2 orbitals with this one. Now this one will be dxz, dyz. This is dz square. This is dxy. This is dx square minus y square. 8 electrons are there now. Then 8 electrons we have to pair up or we have to arrange this particular orbitals 1, 2, 3, 4, 5, 6, 7, 8. This orbital is kept vacant. Here d orbital dx square minus y square orbital is involving. Then this we represent by what delta sp. Delta stands for energy difference. Sp stands for square planar. Then this is the arrangement of electrons, splitting of d orbitals in square planar. Let us come to information part. Hybridization we have discussed well. DSP2 geometry square planar geometry. Number of 100 electrons 0. It is what inverse stands for nature of the complex. nature of the complex, therefore it is inner orbital complex, let me say IOC. Inner orbital complex, 3D is involved, then you can say it as what low spin or spin paid, number of unpaired electrons 0, magnetic moment 0, at this particular complex not carrying any unpaired electrons, therefore nature of the complex is 3D is involved, therefore I said inner orbital, low spin, spin paid, and number of unpaired electrons 0, magnetic moment 0. It is again one more important complex with coordination number 4. One is nickel tetrachloride, second one is what nickel tetracyanide. Nickel tetracyanide. Let me discuss one more, nickel tetracarbonyl, how it will be now. See in the coordination number 4, nickel tetracarbonyl. Nickel tetracarbonyl. The nickel tetracarbonyl, nickel oxidation number is 0. So nickel again, let me put the same steps. Nickel 28, it is 3D8 and again 4s2. Nickel oxidation number is 0, then it is what 3D8, it is what 4s2. The arrangement of electrons in this particular D8 remaining same, 1, 2, 3, 4, 5, 6, 7, 8, 6, 7, 8 electrons, and F's electrons are there in this. Here it is what D8. Then this particular CO, let me write the first complex, nickel tetracarbonyl. See, it is well known to you, we already taken CO is what actually again a strong field ligand. Wherever strong field ligand is there, the electrons have to be getting paired. Now, the pairing of electrons, you consider S electrons also shifted to D. This is important to remember in this particular nickel tetracarbonyl 3D, and again 4s and 4p. 4s orbital and 4p orbital, right? Now, electrons from S is shifted to D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. S electrons shifted to D. Then coordinate number is 4. Then sp3 hybridization, 1, 2, 3, 4. This is what sp3 hybridization. Once sp3 hybridization is there, we can say that is tetrahedral. Let me show the splitting of orbitals in now tetrahedral geometry. In this now D is carrying what 10 electrons. I am writing 10 electrons. 10 electrons in this particular D orbitals. Then splitting, how splitting is taking place? Consider tetrahedral splitting. This one, this higher energy level, you know, T to this set of orbitals in tetrahedral, let me say T, and the lower energy level, this is coming to be E set of orbitals. Then splitting, say this is delta T. Arrangement of electrons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the arrangement of electrons in nickel tetracarbonyl. 10 electrons arranged in this particular d orbital. Coming to the information part. Information part, we take this particular information for nickel tetracarbonyl. Say hybridization, we are shown on the board sp3. Geometry well known to us, it is tetrahedral. And complex, no d orbital is participating, either 3D or 4D. Let us nature of the complex, leave it. Coming to number of unpaired electrons coming to be 0, magnetic moment 0. This is the about this particular information about this particular nickel tetracarbonyl. So 3 complexes we have discussed: nickel tetrachloride, nickel tetracyanide, nickel tetracarbonyl. The 3 are coordination number 4, but 3 are having 3 different hybridization, 3 different number of unpaired electrons and all. The 3 complexes are very, very important. The difference you understand, and what is the difference between the 3 complexes, either hybridization, number of unpaired electrons and all. So these 3 are very important. I have seen many questions on this particular 3 complexes.